skateboarder accelerates from 1.8 meters per second to 3.2 meters per second over a distance of 5 meters in an attempt to outrun an insane math professor. Boy, that's an interesting situation there. But anyways, what was his average speed over the 5-meter displacement? Well, we've just learned, kind of in connection, I think, with the third kinematic formula, that the average speed can be given by the arithmetic mean of the initial speed and the final speed. So that's v naught plus v over 2. And so really, I think based on the numbers that I have here, I think we can recognize that v naught is 1.8 meters per second. V is the final speed is given to us as 3.2 meters per second. I think that's pretty clear the way that's worded, that those are initial and final speeds, all over 2. And you can put these numbers into your calculator, and this winds up at 2.5 meters per second as the average, or based again on arithmetic mean. Then it says, how much time did it take for the skateboarder to speed up from the initial speed to the final speed that were given there? And I think the approach to this is to remember that the third kinematic formula really is just kind of an extension of the rate formula to situations involving constant acceleration. I mean, the rate formula in mathematics usually doesn't allow acceleration, but in this case, we're saying, you know what? Acceleration is allowed as long as you say distance is equal to average speed, or maybe average velocity, times time. And we just solve for average velocity. We're given delta x is equal to 5 meters. So if our question is how much time did it take, we can solve for time by dividing both sides by v bar. And I sometimes like to say something that sometimes I work with numbers, but physicists like to get comfortable working with expressions. And so instead of plugging in the numbers here and then doing algebra, I'm doing the algebra first and then plugging in the numbers later. And it's good to get in the habit of being able to do that, because it winds up being very useful as we progress into physics. So in this final step, now I can put in with units the numbers that I know for these quantities, and I get 5 meters divided by 2.5 meters per second, and that looks like it's just equal to the number 2. Maybe I'll make it a 2.0 because it looks like everything's kind of at 2 sig figs there. Meters per meter per second, though, I think winds up in seconds, which is expected for time. So that, again, is my second answer. So let's go ahead and check it, and it looks like it all checks out.